Today's lesson, section 4.3a, talking about logarithmic functions. So the definition of a logarithmic function is let a be a positive number with a not equal to 1. The logarithmic function with base a, denoted by log of base a, is defined by log of x base a is equal to y, which is also the same as a to the y power is equal to x. So here what they're saying is that we're told that a is our base, and so if we went back to an exponential function, a is the same base as what it would be in the exponential function. X and y kind of reverse roles, where you take log of x base a, which is equal to y, so y is just representing your exponent. So what they're trying to tell you is that if you have a log of a number with a certain base, then that is equal to that specific exponent for that base. So in exponential form, it'd be a to a certain power is equal to x. So that's how they kind of correlate with one another. So base, exponent. Okay? So log of x base a is the exponent to which the base a must be raised to give x. Okay? Example 1, we want to be able to change them from exponential or logarithmic form to exponential form. So kind of like what you're given up here from left to right. So if it says log of 100,000 to base 10 is equal to 5, then 10 is your base. So I do 10, and then this is my exponent. So I do 10 to the 5th is equal to 100,000. Okay? And so then that would be exponential form. Now in the reverse, if I did exponential form to logarithmic form, then I'd still do the same thing. It says log, and now with the number that is equal to it, so log of 1/8 with the base of 2, that's equal to the exponent of -3. Okay? So that's kind of how we change from one form to another. This will be helpful once we start trying to solve for logarithmic and exponential functions in an equation format. If I want to be able to evaluate the following logarithms, I can use this property to help me solve as well. So one thing I always like to do is I set it equal to x or a certain variable, doesn't matter what it is. So you could say k if you wanted. And then I change it to the other form. So here, log of 32 base 2 is equal to x would be switched to 2 to the x is equal to 32. So now I get to ask what 2 to what power gives me 32. So I can either guess from there, or I could also rewrite 32 to have the same base as 2. So 2 to the x is equal to, I believe, 2 to the 5th. So that means that x must be 5 for that to be the case. But if you already knew that 2 to the 5th was equal to 32, you don't have to do that step. That's just a step to kind of help you connect the two to each other. Letter B, it says log of 4 base 16 is equal to k. So I switch this stuff around. So 16 is my base, k is my exponent, and is equal to 4. Now this one's a little weird because your base is bigger than your other number on the other side. So we need to readjust. So you could also say that 16 could be written as a base of 4, right? So 4 squared to the k power is equal to 4. So it gives me 4, 2 to the k equals 4 to the first. And one of the nice things here, if you have, kind of like I did in the last one, if I have the base is the same thing, you can write a new equation to help you solve for the exponent. So 2k is equal to 1. So then I would divide by 2, which k would be 1/2. Okay? And so then that would be my answer. Now here there's a couple properties that we'd like to talk about. So here one property is that log of 1 base a, or any base, is equal to 0. So what they're saying is that if you change that to exponential form, that'd be saying like a to the 0 is equal to 1, which we already know that any power to 0 power, or sorry, any base to 0 power is always 1. Same thing here. If I change log of a base a is equal to 1 to exponential form, to prove this, you're saying a to the first is equal to a, which we know is true. Okay. 3 says that log of any value to the x power to that same base is equal to x. So here, changing it up, so you'd say a to the x is equal to a to the x. So when your bases are equal, the exponents are equal, so x equals x. Now here, this one's a little different, because you have a to a power is equal to x. Here you'd have to switch it to log form, so your base is a, and this is what you're taking it to, so log of x base a, which is equal to log of x base a. So just like it's saying. Okay? So those are a couple properties that we'll use to help us simplify certain things. Okay. Couple other things that we need to talk about is a common log. Now this is a logarithm with a base of 10. So and this is called common log and is just denoted by omitting the base. So if I have 10, I could surely write that as my base, but it's the same thing as not writing it. So this is the log of x button that you have on your calculator, which is what they're trying to say is it has a base of 10. Okay? The natural logarithm has a base of e, and is called natural log and is denoted by ln. So on your calculator, you see this. Okay? What it means is this, log of x base e. So if you change that to exponential form, you'd say e to the, and then you could say y, e to the y is equal to x. Okay, just like it says down there. So just imagine this ln of having base e that you just don't write, and that's where the kind of switch kind of happens. Some more properties. Natural logarithms have the same type of properties, they're just with the base e more specifically. So if we say ln of 1 is equal to 0, that's just saying e to the 0 power is equal to 1. Okay? Ln of e is equal to 1. So here we're just saying that e to the first is equal to e to the first, basically, because there's a 1 exponent there as well. And then for 3, we say e to the x is equal to e to the x if I wanted to switch that around. So that's why ln of e to the x equals x all the time. And then same thing for this one. We would change this to logarithmic form. So then, because you have an e there, it's log of x base e, which is equal to ln of x, which we said was the true statement up there. Okay? So now we want to be able to evaluate with the following logarithms. If I have ln of e to the 8th, remember that's one of our properties, so if you go back to this one, number 3, we have ln of e to the x power, it's just equal to the x, so that means that this has just got to be equal to 8. If you didn't want to use that, you could use like the switching and set it equal to a variable and then switch, so e to the y is equal to e to the 8, so that means that y is equal to 8 in that sense. So same answer, just a different way of thinking about it. Now sometimes you're just given a number, so like ln of 5, there's no properties that go with that because 5 doesn't have a base of e. So then that means we just need to plug it into our calculator. So find your ln button, plug in 5, close your parentheses, and then plug it in. So let's say that we round it to the 100th. So 1.61 would be my answer. Okay? Have fun.